Okay, everyone, welcome to our Maxam webinar. The title is How to Best Maintain Your Mining Haul Truck Tires. I imagine there's quite a few of you in the audience today who are involved with mining tires, either as a user or supplier. You're already quite familiar with Maxam Tire, but some of you may not be. I'm going to leave the official introduction to our speaker, Phil Domm, who's Mining Tire Sales Manager at Maxam. But very briefly, the company is a leader in specialty tires, including large radial tires for mining. It's headquartered in Danvers, Massachusetts, and is a part of China's Sailun Group, which has 8 manufacturing centers and 4 R&D centers worldwide. Maxam emphasizes quality, reliability, and consistent performance as key attributes of its tires. And the vast majority of today's presentation is, as you would expect, not about the company, but is really focused on the challenges and problems faced at rail mine sites with a focus on maintenance. Maxam has a boots on the ground approach, and Phil's going to take us through some case studies that really illustrate what can go wrong with mining tires in terms of wear and damage, but more importantly, some of the reasons why these are happening and the steps that can be taken to mitigate these issues. Before I introduce Phil, I want to say that we'll have a Q&A at the end of the call, so feel free to submit your questions on the chat function as we go along, and any that we're unable to get to, Maxam will collate some written answers for following the webinar. So I'm not going to delay any further. Let me tell you a bit about our speaker, Phil Domm. He joined Maxam Tire in April 2020 as mining account manager for the Southeast and Central States, responsible for all mining tire sales for both surface and underground. And he came to Maxam Tire after spending 15 years with Michelin OTR and Giant Mining Tire Groups. He's held multiple roles as Earth Mover Sales Manager, Mine Site Account Manager, and Global Mining Account Manager. Phil has worked with and visited mine sites all over the US and Canadian markets, and has also worked with global mining customers and their operations in Australia, South America, Africa, and the Dominican Republic. Phil has also managed OTR tire tracking systems, and says that he enjoys particularly the technical side of the industry and the challenges that come with that. He has a BA degree from the University of Utah and resides in Greenville, South Carolina. So it's a pleasure to hand over to you, Phil.
Thank you. Nice to meet you and appreciate the opportunity here. I'm going to share my screen here. And we'll go through a presentation that I put together for us so we can look at. Here we go. So the key is we'll go through the summary of what we're going to do today. We're going to look at who Maxam is. We're going to look at a few case studies of tires, tire conditions, and drill into a few details on speeds and turns and downhill ladens. I wanted to make this more of a working opportunity to kind of show specific case studies so that we could kind of go through and dig through what is Maxam's approach on how to resolve issues and work tightly with our customer base and our dealer network. First off, I'd start with who Maxam is. We, as Paul indicated, we are the specialty group for the Sailun Group, and we cover all things earth mover, from the smallest of the small to the largest of the large. We're going to make the earth mover tires for the industry. We make all the way up to the largest mining tire and even down to the small forklift tire. Our focus is on that, and we have been doing that for about 8 years with substantial growth every year. One of our backgrounds and benefits with our company has been within the Sailun Group is the Sailun Group has what's a company called Mesnek. Mesnek is the tire building machine end of our company. So we not only do we build tires, we build the machines that make the tires, giving us a lot of cutting edge technology for how we build tires, processes, and the efficiency on what we do. Going forward, our approach, as you said, we like a boots on the ground approach. We value that the customer is the number one concern for us. We want to make sure that we provide the right product for the customer in the right opportunity, the right mine site, the right application. And we do this through constant improvement to our product, through research and development. But the way we get it done is through boots on the ground. In this industry, most companies are reducing headcount in the field. We are increasing our headcount everywhere we go to make sure that we are the face in front of the customer for the product. We feel that's a valuable concern and a valuable thing for the customers to have personnel that are highly well trained and technically minded, that they can handle issues and concerns that come up. We don't want to just sell a tire. We want to be a business solution provider for our end user and for our customers. This part is a case study that we're going to start looking at. And a lot of times when you're faced with an issue or a tire concern or a question from a customer, we want to look at it from a lot of different angles. This is a situation that I came across a couple years ago in the high desert of California. This is an aggregate mine, and they are up in the high desert where it gets pretty hot, and they have some altitude to their hauls. They run 2 shifts. They run 24 hours a day. They run 100-ton haul trucks, Cat 777 haul trucks, and they run about 8 of them. So they're not a very large mine, but they're a very effective mine. I want to show you a quick video of the mine site so you get a favor or a taste of what the mine is like. So give me 1 second here. So this is a relive video that I did at the mine site, where we take pictures of the haul road, of the loading areas and the dump areas, to give you a vision, to give the mine site a vision of what the haul roads look like. You'll notice in a lot of these hauls, very arid conditions, lots of rocks on the road, lots of opportunity for trucks to hit rocks and to damage tires. Undulations here in this small video where the road is not that smooth and the tires can bounce in the haulage process. You'll also see here in this video that there's some altitude here. We'll drive into the details of the altitude in a little bit, but this is a good tool that we use at Maxam to kind of show the mine the conditions of the haul, how the haul works, any notes that we would make for the haul, and any concerns we would have to work with them on. The final part of this little video you'll see is the long ore haul on the way down, and we're heading downhill. And then this hairpin turn right to the final crusher. So this is a tool that we use in most cases to show the conditions of the haul. We compare it to the last one we may have done, and to show kind of where problem areas might be, where we need to pay attention, and what we can do with the mine to kind of make things a little bit more fluid and healthier for tires at the mine site. I'm going to go back to the earlier presentation. At this mine, a concern was brought up to me and our local rep that we were having some irregular tire wear. And you can see in the picture to the right, the left to the right, there's a definite difference in the tread wear. The blocks on the left were wearing faster, more of a heel-toe wear, and scrubbing off a lot faster than others. So there's a lot of concerns when people have that, because obviously you're not going to get the full use of the tire when you start getting irregular wear. We want to be able to find out, why is this happening? Because if it's happening on one tire, it could be happening on 5, 6, 7, or 10 other tires. So the idea is to look into it in detail and find out where the causes are and how do we approach this. What we found with this is that we had 3 issues. We had uneven tire wear, we had some flange bulges, and some cracking in the flange area. This is what's called oblique cracking. If you look under that flange area, you'll see that the rubber is actually stressed to the point where it's cracking. and it's starting to come apart a little bit. The question is, why does this happen? Normally this is happening because of over deflection, whether that's underinflation or there's too much stresses on the casing. We need to try and determine why. Another issue they came across, or we came across there, were some bulges. So there are bulges in that same flange area. And that's where the rubber is actually starting to come apart on the interior there near the steel. That's another indicator of overstresses by either underinflation or overload, and very well could be road conditions if we can identify the road conditions. So I run into this situation. I go, okay, now I got this tire with irregular wear and two other concerns that I want to identify. How do you approach that? We have there might be overinflation or there might be underinflation in the situation. There might be high lateral forces to this tire, and are there any other issues? So the question I come up with in this case is, what do I do to try and figure out what's going on and what's causing this tire to do what it's doing? That's when I go into detailed data. I'll take GPSs, and in this case I took a couple of GPSs on a few trucks, and I mounted them on the trucks for about 2 days or 52 hours or more. So we throw GPSs on the trucks, and what we're doing is we're monitoring every movement of that truck for that period of time. We're looking, in this case, on truck 56, we got 76 miles of distance traveled, 85 cycles of material moved, and 52 hours. We monitored about 4 shifts and 1 partial shift. We looked at this days and nights. We really want to dive in and say, okay, why, if there's a problem, where's that problem? And if we can identify the problem, we want to be able to offer solutions to the customer to help with those problems. In more detail, this is more detail of what I was able to determine. The map on the right is the haulage of the truck. And you'll notice that there's a small collection of little hauls with an arrow that says 21 cycles. This truck spends most of its time running, not in circles, but running really short little hauls. They're hauling waste material from one area to another, very short, back and forth, back and forth. And that's all up at a high elevation. And then if you notice in the large circle, they're dropping down in elevation to the crusher. Usually, in this case, it was 3 cycles that day. Other cases, there might be more, 4, 5, 6 cycles. The idea is that they're balancing their long distance cycles with their short cycles, which is a good sign. But then I start digging in and drilling in, okay, what is the cause or what could be a culprit for this issue? And you notice that I indicated a tight turn. That's a very, very tight turn. And I was wondering, could that be a possible candidate for what we were seeing in the evolution of that tire? So what I did is I drilled in with what we saw in the data and also where we're looking at the actual speeds. These are pictures of the approach. So you're looking at a downhill laden haul, and he's coming into basically a switchback that's pretty tight, and that's the approach to his crusher. I found that their speeds were about 11 miles an hour to 20 miles an hour, and there was about a 5% grade at that point, a negative grade. And these are all indicators that maybe this might be a turn that was causing some of that irregular wear and some of those concerns that the customer was having. I drilled into the details even further and looked at each haul over the period of the time that I had the GPS. And I was able to monitor each speed in those turns and compare it to what we would recommend. What I found was that over average wise, they were going about 17 miles an hour into that turn, 17 to 18 miles an hour. We would have recommended 8 miles an hour. So realistically, twice the speed that's recommended, they were taking this approach. One of the last things that a mine wants to hear from a tire person is to slow their trucks down. And that's something I don't like telling people, and I don't telling sites to slow your truck all the way down. But I do say in this situation, for one turn, that was the recommendation. slow your approach in this one turn. It's not going to cost you a lot in your production time, and it will save you probably thousands of dollars in early tire wear as it goes. So the end of it was basically to recommend that they slow into that turn and to actually look at a negative grade, or look at the, basically posting a speed sign there for that turn. The other issue that we would run into is the downhill factor. This truck was traveling downhill laden. So it's picking up an ore level, or an ore, picking up its ore, its aggregate at 4,800 feet, and it was dropping it at about 4,000 feet. So it's dropping about 858 feet in that haul. And as it comes down to that haul where that turn is, he's taking that turn under load. The question could be posed, why is that a problem? Here's the key answer. In the center truck in the middle, that's the way a truck is designed to be hauling, where the load is distributed between both sets of axles evenly, equally, and for optimal wear. Once we start putting that truck on a downhill laden on the far left, what we're doing is we're actually throwing more load on those front tires, more load that's been designed to be carried in the rear. Now it's being carried on the front. And the real question that people will ask is, why is that a bad problem? Well, you have 4 tires across the rear axle of a truck. You only have 2 in the front. So not only are we putting more load on the front, but we're also putting more load on only 2 tires. This can desperately or drastically increase the TMPH, or the ton-mile per hour of that tire. It can increase the load. You're going to have different wear conditions on that front axle. You'll see on the far right, you get the opposite factor, where the load is actually being thrown into the back as it climbs out of the hill. That's actually more ideal because you have the load distributed amongst 4 tires versus the 2. So in this situation, on another factor too to look at is that every time we increase that grade, that negative grade, we can decrease our tire life by substantially. So if we've got, just between going 10% downhill laden, we've got maybe a tire life reduction of about 19% of what we would have seen. If we increase that to 12 or 13%, we get up to about 30, 36% faster reduction in tire wear. Another factor, another thing that I've done at other sites to kind of indicate this and to show this message to customers, is basically mounting a GoPro camera on the front axle of a tire facing backwards. And you can see in this situation, I've got the GoPro, he's traveling about 26 miles an hour, and you can see that casing is pretty straight, and you can see a little gap right above where the red line is, where the strut starts. As that truck goes into the turn, you can see the casing starts to fold a little bit and the strut compresses. Then once that tire is in the full turn, you see that strut is completely bottomed out, and you can see that casing is actually is folding over a little bit. Now, that's where we could run into more issues, because the tire is not designed to fold to the left or to the right like that. And if we do that repetitively, we're going to put stresses on the belt cables and the belt packages, causing those things to start to wiggle and squirm to the point where they might actually develop a gap and what's called a belt edge separation. Usually happening on the front axle, usually happening on one tire in the front axle, where the tire that gets the most of the load. If it's a hard left turn, it might be that left tire. So these are things the tools that we use to help the customer at the end of the day. So one of the things that, again, we come back with helping the customer realize how to monitor their speeds in these tight turns and corners, and how to keep the load positive in the sense of, loading it and the speeds going down into let's say, a downhill laden haul. In this situation, we were able to offer the customer solutions that help them make decisions for their mine site versus just throw money at a problem that could be a continual problem. Making the proper changes to the mine site sometimes will actually is more effective than just throwing let's say, a credit towards a tire. In some cases, you can even bank a corner, and we can talk in detail about that. I'm sure we'll have some questions about that. Banking is something that can be done. In this situation, that turn was so tight that their banking really couldn't be done, but it is an option. So in summary, we're looking at high lateral forces, what that can cause some of these issues, and how do we identify those forces, and then what do we do to mitigate the problem. Looking at inflation, are we going to check the underinflation? If the tire's underinflated, these issues can arise. We're going to look at the turns and the speeds into those turns, make sure that the speeds are the proper speeds, not too fast, so that we can make sure that the damage doesn't occur in the turns. And load transfers. How does the load transfer when the truck is hauling? The number one factor that I see with this a lot that is overlooked is a pre-shift. This is when the operator has that opportunity before he gets in that truck to walk the truck, to look at everything, to look at the tires, to note and make recommendations to his management about what he or she sees. They can be the eyes and ears for what's going on in the truck. If you think about it, operations, production, maintenance, their eyeballs are not on that truck every day, but the operator's eyeballs are on that truck. A lot of times what I do too with helping in this is we do a what's called a driver awareness training, where I'll go through with a safety meeting, and I'll teach their drivers what to look for. We'll do hands-on. We'll walk a truck. We'll teach them how to notify and how to identify good, bad, and ugly conditions on tires, so they know what they're looking at to the degree, so they know what to report and how to report what needs to be done. I think that's the presentation. So hopefully, Paul, that makes sense.
No, I think it's good food for thought and very comprehensive and insightful. We do have quite a few questions that have come through, so we'll do our best to cover those as best we can. First up, someone has asked, is it possible to determine whether it's an operational or a manufacturing issue with the tires, or at what point can you make that call, if you like?
Yeah, you very well can. I mean, many cases it's an operational issue, and it depends on the kind of issue that you see. I've had a situation that a customer mounted a tire, had a bulge within 50 hours, and that's not normal. So that was one that we pulled. I cut open and saw a manufacturing defect that we had to address and take care of. But the cases like these, a lot of them are operational, in like irregular wear. It's like with our car tires, a lot of times we'll see, there's irregular wear, or there's other issues that we'll run into that what we're doing. That's why you kind of have to look at the whole picture and not just the one damage you look at. One of the mistakes I see that people do is they'll look at only the one condition that's complained about without looking at the rest of the tire. So in this situation, they complained about that irregular wear on the front axle. But when I looked at the tire, I found two other conditions that I needed to address, which led to support of more operational damages versus something that could have been manufactured. Does that make sense?
Okay. Another question I've got is, what's the typical life of a whole truck tire? I guess that's pretty difficult to answer. And they've added, is there a big variation based on, the mine type, the tire size, that kind of thing?
Well, Paul, you've been to many mines. You know that all mines are exactly the same, right? No, every mine runs differently. Every mine has a different haulage, a different material. You go to a mine like this, they may be happy with 3,000 to 5,000 hours on their tires. Yet, if I go to Mississippi to a coal mine, they might be getting 16 to 17,000 hours on their tires. You go up into, the Gillette country and the coal country, they tend to have higher hours because the material that they're running on is softer. It's more clay based, or it's more ash and finer material. Versus you go to Nevada, where it's a hard rock gold mining, and their hours are going to be a lot shorter. So every mine is completely different. That's why we actually make it a standard to look at what the actual mine site averages are, so that we know when we're competing. Because a lot of times we're competing with the big guys, and we want to be able to say, okay, brand A and brand B are getting these many hours. We're going to come in and we're going to guarantee that we'll get at least this many hours to compete with them. So yeah, every mine has a different, everyone wants more hours and more miles or more kilometers, but every mine has a different makeup. And, and along those same lines, as a manufacturer, you don't just make one tire, you make a tire for cut compounds, you make a tire for heat compounds, and then one that's right in the middle. And you try and marry those compounds up with how the mine runs and operates so that they get the best use out of their tire.
Okay.
A heat tire is going to last a lot longer when it comes to long distance, but when you put it into the mine like we just looked at, it's going to just get destroyed within hours.
Okay. Next question from the audience, which you thought you might get. With banking being difficult to maintain, what's your best advice for other mitigating measures to take? So a specific question about the banking.
Banking is ideal if you can do it. I don't see it done very often because of a couple key factors. One is the distance. It takes distance to do that, to build that. It takes the manpower to build it. And then you have to maintain it, because if you think about it, we're not running on asphalt or concrete. We're running on dirt. And so the more that you run into that bank, the more that dirt is going to be pushed up and pushed up. So there's a maintenance factor to it. The places that I see that are successful at it are like the large aggregate mines in Florida and other places where they have distance and they have the time and manpower to maintain those banks. Florida is a good one because they do a lot of dragline mining, which is really digging big giant water pits. And then they have straight line hauls, and then they have 90-degree hauls. So they have to attend this 90-degree turn at full speed. So what they do is they do try to maintain a banked type haul, but generally they're not as common, primarily because I think they're difficult to upkeep and build. In a perfect world, it would be great, because if you look at it in the racing world, we use bank current turns in racing to try and keep that momentum on the ground and keep the load even on all those two axles. Excuse my cough.
Yeah, I mean, from my side, talking haul roads that I've seen, as much as people in the industry like to think that, your main haul roads are semi-permanent, in some of the real high throughput mines, like the copper mines in Chile and Peru, they're moving that whole road, possibly a couple of times a year, or so I guess you're right, maintaining that bank part of the road. It's just maybe they see that as an extra whole road maintenance cost or duty that it's difficult for them to keep that up, or if there isn't a culture in the mine of maintaining the roads that way, I guess it becomes a change management issue.
Yeah, that's exactly it. And then the other factor that we have to consider as being contractors or in the sales side is that we may think that banking that road is going to save them, say $200,000 in tire wear. But they're going to do the cost as the banking and the upkeep, and they might see that they're going to spend $400,000 upkeeping it. They're going to say, you know what, it's acceptable to have the loss of tire. And that's where, whereas on our end, with any suggestion, we just give the suggestion. It's up to the mine to implement or not.
Okay. One of the things that's one of the audience members has queried or mentioned is you didn't mention TPMS or Fleet Management Systems, FMS. Do you recommend using them as an additional source of data for tire monitoring? And is that something is that data that you're using regularly as well?
I'm glad they brought that question. That's a great question. That is where the industry is headed, and that's where we're going with everything. It's taking us longer in this industry than, let's say, in our passenger tire world, mostly because it's not mandated. But we have our own system, which we're implementing here in the U.S., and it's running all over China. That's ideal. Those systems are great because they're going to measure two key factors. They're going to measure, of course, the tire pressure, and they're going to send alerts when that tire is low or if it's overinflated, and you're going to know if there's a problem tire, and hopefully save you some downtime. The other factor that those systems offer is a temperature. They offer you the temperature where they'll tell you, okay, your tire's getting too hot. Heat is the worst thing for a tire. If you overheat a tire, the rubber will revert and it starts to come apart, and there's no way to make that tire better again. So the idea is we want to run. Someone once told me these gentlemen these mines don't buy tires to run them to a third of their capacity. We're buying the tires to run them to 100% of their capacity. How do we know where that threshold is? Those tools are the ones that are going to tell us exactly where those thresholds are. My coworker in Nevada, he worked for a large mining company, managed a tire shop in Nevada. He ran a system like that, and he would get notifications of where they were, let's say on the green to red level on temperature. And he would come in and he'd say, okay, we're at yellow or we're at green. He would actually call mine management and say, speed up your trucks 5 miles an hour. You'll make $2 million more because you can run faster and it's cool out and you're not going to melt your tires. So there's productivity values to those systems as well. And then if you get into the final factor with those systems is the GPS, geo tracking, but the GPS factor of those systems. A lot of systems are equipped with GPS where we can do, where I put these little Garmin type GPSs in that truck that we just looked at. Those guys can get that information instantaneously because it's on the truck. So, but the other factor too, there's a cost to those. So there's a cost to the system to implement, to install it. There's a cost for the sensors that go in the tires, which are not cheap. And then there's the maintenance. You have to have someone mine site level that owns the system, that takes ownership to make sure that the system is working. So it's ideal, but it's hard to implement if you don't have the buy-in from different aspects of the mine.
And I guess it's like, you were talking about the first case study, a relatively small mine, 8777's aggregate operation, rolling out TPMS for them may not be a priority, but, somebody like Nevada Gold Mines probably has it on every vehicle already. So and there's something, everything in between, I guess. From my point of view, I certainly see a difference from, 5, 6, 10 years ago where these TPMS systems were being rolled out as kind of pilots or trials or, let's play around with it. But it certainly seems to be becoming, certainly in the bigger mines, more of a standard product or standard fitment now. I don't know whether you see that as well.
Yeah, I definitely do. And I see a lot more companies trying to get into that world, that industry. One of the things that a lot of them some of these systems will put out like a valve stem type sensor, which is decent. It'll measure your air pressure. The ideal ones are going to be a sensor that's inside the tire that's going to give you a true measure. What you're really trying to do, and what the tire nerd in me wants to do is to be able to monitor. Okay, what is the internal temperature of that tire, and then correlate it to the belt package where the belt is, because that's the key factors. We want to make sure that that belt package doesn't get too hot. Steel retains heat, so once that steel has the heat, it's going to retain it, and then it's going to distribute it all the way around. And so that's the real, like you said, these small mines like the demo I had today, it probably wouldn't be feasible, I don't think, unless it was a cheap system for them. But like you say, the Nevada Gold Mines and Barrick and the large scale mines. That's where they're going to see that. Rio Tinto is real strong at it, and they use it as a strong tool. And in some cases, they get those systems to communicate with the VIMs and the other systems within the trucks.
Okay. Still got a few more questions that have been asked. I guess we've covered part of this already, but do you see a big range of haul road conditions at customer sites? Aside from loading zones, what are the most common problem areas when it comes to tire wear and damage? So, like, it's outside the obvious shovel loading area with rocks. Where are the kind of other typical? I think your presentation mentioned switchbacks and tight turns and that kind of thing.
Well, I think that's where you really have to know the customer and know how they haul. I've got mines, like I said, in the south that are just flat. There's no elevation and flat but long. And then you get, I work a lot with up in the Iron Range in Minnesota, and then you put that against mines in the Black Hills or elsewhere. So every mine is going to have a different type of haulage pattern. Getting to know the haulage patterns is critical for helping to be the right solution provider to them. Like we said, I mean, the different types of hauls indicate how the tires are going to wear and what we can recommend, and in some cases even tread patterns. For instance, in our, let's say, 150 ton hunt truck world, our 785 world, we introduced. We used to just have one tread pattern for those lines. Now we actually have come up with 3 and a deep tread, so technically 4, trying to fit the need and the of each mine. There's even mines that require high speed tires where we're building we need to build a tire that has a very shallow tread to it, because the haul truck might go 14, 16 miles, 25 miles. Okay. So it's amazing. I remember being at my first coal mine in North Dakota, and we're riding out to the coal seam, and it's a long ride. And I kept asking the guy, "Where have you mined already?" And the guy goes, "Right here." I go, "What do you mean, right here?" And I go, "This is just farmland." He goes, "Well, we've mined this." He says, "But," I go, "you got to haul this all the way back." He goes, "Yeah, every load of coal is hauled, 16 miles one way." So, it's a matter of trying to figure out how do we do this. Sometimes it requires us getting our research development people to come on site and understand for real. Either company I worked for, we've done that. Because sometimes you just can't sit in a lab room and figure out the best thing for a mine. You need to see how they actually work them.
And it's one thought I had is when you get to that kind of smaller mine category, 60, 70, 80 tons, there's a kind of gray area between, should I use ADTs or articulated trucks, or should I use rigid trucks?
Yeah.
Is there a tire factor in that as well? Like, in that rigid versus ADT decision, do tires form part of that? Are tires for ADTs typically behave in a different way, or typically cheaper, or how does that come into the equation if they're looking at one or the other?
I think they need to, you get into that world, then you're. I was at a mine last week in northern Minnesota that actually more of a contractor, but he's using predominantly rigid dump 785 or 773 small dump trucks on a tire that's a 2435. But I saw we call them wiggle wagons. I saw the ADT trucks coming through with virtually about the same tonnage, and we were talking about it. And mostly for them, it's a necessity just because they want to move more material. But I think it's a tough choice for those guys to try and figure out which is more effective, usage-wise, haulage-wise. I do see that the articulated dump truck tends to do a lot better when it comes to uneven and more off-road type areas where they haven't been able to get in a grader and smooth out. Let's say they're loading out of a really gnarly area that's tough. Those trucks tend to do a lot better than the regular old rigid dump truck frame. But yeah, you're right. I mean,
but the tires themselves on an equivalent, let's say a 60-ton ADT versus a 60-ton rigid, the tires are pretty similar.
They're designed differently, of course, because the machines are different, but they will wear very similar. The ADT truck is a much wider base tire, so that versus the haul truck tire, and then you're dealing with the configuration of 3 axles versus 2 axles but 6 tires. But yeah, so there are the issue you can run into with some of those situations are a lot of those articulated dump trucks are piecework, so they may come in with, let's say, the wrong tire on them, and they just run them with whatever tires on it, and that's so that's where we have to kind of watch and make sure that the proper tire is going in. Like, for instance, it could come in with a shallower tire versus a deeper tire, and it might need the deeper tire, or it might come in with a deeper tire, but it has a longer travel, and it's going to build up heat more. So, and I think a lot of those decisions are based on the kind of tonnage that they feel they can move with those different machines.
We've had a couple more questions. What's your attitude towards tire retreading in mining, and does that often just create additional issues or problems?
Obviously, I prefer to sell new tires because we make new tires. We don't make retreading. Retreading is a viable option out there for people. I have good friends that run retread operations and own retread shops. So, I mean, I understand the need to retread. My personal feeling and my personal take on it is that retreading works better in the smaller sizes. Once you get below a giant mining truck, I think it works a lot better. I've been to some mines where they'll use retreading on a giant truck, and the math to me doesn't work. For instance, I was at a mine that retreads giant 57-inch tires. And so in order to retread that tire, they've got to pull that tire with 50 millimeters left, and they got to buff it off. And then, they pull the tire with 40 mils left. They buff it off to retread it with 60 or 50 mils. I'm just thinking why, and then you have a cost incurred with that. You're increasing your millimeters a little bit, but then you're adding a cost to pay for the rubber and the retread. Whereas what we would have recommended is just run our tire to destruction, run our tire to the point where you see steel, and then pull it. Because in order to retread, you actually have to pull the tire early because you want to be able to have good rubber underneath it. So you have to pull it early and then buff that rubber off. And so you're losing some rubber in the initial point of it. Where I do see retreading work real well for mines are on like really heavy support equipment, like the big 24M graders and those guys. And see, even on water trucks, I see retreads work well with those, where they can manage their casings and they can do real well with that. One of the things that we find in our group with Maxam, because we are more cost effective for many mines, is that we actually can replace the retreading option based on our wear rate and our price point. So it becomes kind of a null and void question for some of them.
Okay. Do you see different wear effects at customer sites from different approaches to tire rotations, as well as mixing tire brands on one truck?
Yeah. In a perfect world, you're going to want to mount a Michelin next to a Michelin, a Maxam next to a Maxam, and the rear axle. I mean, obviously rotation, like what we do with our personal tires, if we rotate our tires, they're going to last longer. It's the same with the haul truck. Traditionally, your new tires are going to mount to the front axle. They're going to run to about 30% of wear or tire tread, or hours, and then we're going to rotate them to the rear axle. Some mines are so specific that they will rotate, let's say, from the front axle to the left rear axle, and then they'll take the second life and they'll rotate them to the right rear axle. And they're doing that because, let's say, the right rear axle might be where the most damages happen, and they want to put the worst tires in the most damaged areas so they don't waste valuable rubber. It takes a lot of management, fleet management, to do that, and it takes a lot of coordination and buy-in from the fleet to do that, because there's a cost every time you pull one of these tires off. There's a cost in manpower. A lot of these mines that do that tend to run their own tire shops, so they have their own personnel on site and they have it pre-planned. But even then, you also have the downtime of the truck. So when the truck is not running, it's not hauling coal or minerals that it needs to haul. So there's case studies for all of it. There should be some form of rotation policy at the mine site. It's very hard when you go to a mine and you walk up to a truck and he's got brand new tires across the rear axle because they just don't have anything else to put on the rear. You're probably going to lose about 20-30% of your tire life just if you do that, because of the torque that's on that rear axle, not giving it the free rolling axle on the front third of its life. But the other thing too is what that goes into this is really spare management. Is by rotating off the front, then you can create spares so that when a truck does go down, you're able to match up the right size tire with the right tire. When it comes to matching tire to tire, like I said, it's ideal to match a brand, the same brands. That's primarily because even though a tire might have the same sidewall nomenclature, it might say that it's a 4690/57. But let's say a Michelin 40, or let's say a Bridgestone 4690/57 and a Goodyear, they might be a little bit different. And that's where we want to make sure that we understand what the actual the diameter of the tire is to match them properly. One of the things one of the problems that you run into, and I ran into this last week with a site I was at a little bit, was if you don't have spares, then you're mounting a new tire next to an old tire. That new tire is going to take more load, because the new tire is taller and it's not going to and the other tire isn't going to take as much load, so it's going to be a little bit higher. So casing management, and I'd say like spare management, goes right in the lines with rotation planning,
Okay. Another question. What is your opinion on compressed air tire alternatives like solid tires, pneumatic cylinder tires, and similar alternatives in the industry? I guess that's Michelin had that Tweel thing, didn't they?
Yeah.
And do you see a future for any of these? I don't want to say off the wall, but more maybe on smaller vehicles in the future.
I think that's probably the next huge change down the road if it happens. The Tweel it's a good product. I mean, when I got hired at Michelin 20 years ago, they had the Tweel, and they were just implementing it into product service more when I was leaving about 5 years ago. So I think where it I think knowing where the place is for it, building a non-pneumatic type tire for a giant haul truck will be completely different than building it for a golf cart, or in those cases they put them on John Deere mowers for like golf courses, or ATVs. Knowing the technology, I've seen some really interesting designs out there. I've seen some odd non-pneumatic type opportunities that the mines have tried, and the dilemma is that once you get into this large world, this giant world, it gets really difficult. I mean, it's just difficult to build a standard tire from, let's say, a 100-ton truck to a 200-ton truck. Once you get the 200-ton truck running, a tire running, just jumping from a 200 to a 300-ton truck is like a whole nother world. So, and you're just talking about the same kind of pneumatic filled air casing. So there's a lot to be concerned with. Solid will never, I don't think solid could ever work in the mining world, because there's just too much heat buildup and they'd have to run too slow. But in the solid world, or let's say the filled world or others, underground mining is where I really would see that some other kind of technology could really do them some real benefit. because underground is a horribly aggressive world. You don't even know what you're running. Over half of those machines are now autonomous, right, or remote. So I mean, you don't even have an operator feeling it. You got a guy with a joystick if you're lucky. So you don't really know what you're hitting, what you're running into. So I think that's probably where we'll probably see the next non-pneumatic type, if they're smart and they work it out. But
Okay.
yeah.
All right. Well, we're coming towards the end of the allocated time. I think there are some more questions, but we will hopefully get those responded to in writing following the webinar. But thank you very much, Phil. It's been really insightful and really enjoyable discussion. And thanks for taking the time.
I appreciate it. Thank you very much.
Thank you very much.